Seems to be working. So I just started trying to stream and it didn't work, but it looks like it is fixed now. So what I was saying before is that I'm gonna try to implement a serialization for nodes, a class that serializes node connections. So I'm gonna explain the problem and what I'm trying to do there. And then I'm going to do Anki a little bit. Then after that, I'm gonna try to solve it. And I'm not sure if I'm gonna be able to do today. And if I can't do it with this approach, then I'm probably gonna try with the other approaches, because there are several different approaches. But this one that I'm gonna try now, I think is the easiest one and probably the best. So that's that's why I'm going to try this one first. I'm just gonna wait to make sure that it is streaming. Okay. So basically the problem is that I'm trying to create scenes on Godot from code. And the issue is that if you make connections of signals from two different nodes without putting the connection inside of the constructor of a node, then the editor and the engine are not going to be able to create the connection because the connection happens at runtime. So if you make the connection as part of the constructor of a node, then it's still going to work, because what the editor and most likely what the engine does, I'm not 100% sure about the engine because I haven't looked into the process yet, but I'm pretty sure it is the same, is that when they initialize nodes, they're going to call the memnew, which is a macro that, this macro here that Godot uses to allocate memory on a memory pool. And this is going to run the constructor of the class, which for probably all of the things that you're going to use are going to be inheriting from the object, which is the base class of everything. And it's basically going to run the code inside of the constructor. So if you put the connections of signals inside of the constructor, then you don't need to cache the connection on the scene. Because the way that it works is that both the editor and the engine, they're going to use the scene files to store the states of your scene or your game, and so store basically read and write operations. So it allows you to cache or to save the state of the game, which is basically the data that makes up the game. So in order to do this, they have two different classes. One is resource loader and the other is resource saver, and they both have functions and different savers for different kinds of files that they use. That allows them to, they have some logic inside of the function that is going to take the class from the class DB, which is the main class on Godot that is going to manage the types, all the types that the engine is going to have. So whenever you need to create a new type, you have to subscribe that type on class DB. And you need to register the functions for the type and also the properties for the type, which is basically classes that are going to hold the state for that class, so that the editor and the engine can reconstruct a class based on whatever is written here, and so that they can also save the state based on whatever the class has. So the function that they're going to use to do this is get property list for saving the properties, for example. So in this case here on the scene file, this scene has one node 3D, another node graph 3D, and then this graph 3D here has, it saves the state of the member variables of the graph 3D on the scene. And it does that by using the get property list function, which is going to use, I think, class DB or something like that to get the properties that the class has at the moment that the class is being saved, the node is being saved into the file. Then it's going to get the values of those properties and it's going to save as a sub-resource, or it's going to save on this format here, depending on what kind of the type, what is the type of the property. So scripts, for example, GD scripts, they are saved as an external resource. So this is like an example, which is a script that I attached to this node. So it's saved like this, and then it has a ID here, and it's basically connected based on the ID. So at the moment that the editor is going to construct a scene, it's going to get the state from this file, and then it's going to be able to parse the file and know what was the previous state that the node was saved on, and that's how you're able to recreate the states based on the resources. And as far as I understand, the engine works in the same way. But the problem here is that there is no mechanism so far to save the signals, unless you put it inside the constructor, as I said. So one of the approaches that I was trying to make it work is by learning how they save the script. Because the way that as far as I understand now, based on the tutorials that I've seen that people talk about, the way that people usually do it to connect signals to nodes is they create a script, then they attach to a node, and then either you put the connection inside of the code from the signal, you create the connection, so you access the current node that is attached to the script. In this case would be Graph3D. Then you call the connect function, and then you connect the signal that way to another whatever function from whatever node you want. Or you can go on this tab here, which is on the right of the inspector. And then these are all the signals for all the classes. So each one of the boxes is a class on the class hierarchy for the current node that is selected. And then each one of them has signals that are registered as part of the class. I'm pretty sure I can look into the... So if you go here, I think it's add signal. Yeah, so basically here, this macro here is the one that they use to register the signal on class DB. And a class can only have the signals that it registered using this. So what shows here is going to be whatever the class has inside of the bind methods function that uses this macro, add signal macro here. And the reason why those signals are there is because the way that they design the classes is that there are several different points in the rendering cycle where each class is going to have its own specific signal that is going to emit by default, which allows you to, when you are creating an instance of the class, to connect the class to the signal, and then emit a call, and then run a callback function depending on what is the signal. So the classic example would be a button, for example, where you create a button and then you have the signal called pressed. Then you connect the class that instantiated the button to the signal, and then you run a callback function, which is like what happens after you click the button. That's usually like what people do. And this is always the function that is going to be used to subscribe functions. So use bind method to subscribe a function, and use add property to subscribe a property. And you use add signal to subscribe a signal on the class DB. So the way that people do it is they select one of these, right click on the mouse, and then they put connect here. And then here, it allows you to create a function that is going to be the one that runs after the signal is emitted. And then inside of that function, which is basically what I did here already, which is this function here that I created on this script, which is going to be executed after the ready event. After the ready signal is emitted for Graph3D, then you can like drag the node here, and then it shows the path to the node. And then you can do whatever you want with the nodes there. So it's basically creating, like this is going to be a callback function that is run after the signal is emitted. And it's creating a bridge between the emission of the signal and the whatever functionality you want to execute after. And then it allows you to connect to different nodes that are part of the sync tree by getting the path of the node. So basically what's happening on the lower level is that the sync file is going to be viewed as a resource by Godot. And the object class, which is the base class of everything that happens on the scene, is going to have the member variable, which is the script instance of the object class, which is going to run at specific parts of the rendering cycle. And then that script instance, I think that is not directly the script instance, but is in the case of the GDScript, is the GDScript class, but it's connected to the script instance, but I don't know the relationship for sure. But basically the GDScript class is going to be the one that is equivalent to the file, let's say, because it's going to parse the file, the code on the file, and it has like predetermined functions that are registered with another macro as well. I think I can see on the nodes class. They use another macro to subscribe functions based on another file that are going to be run at different parts of the cycle. And those functions, are the ones that show up on the GDScript file. Because what's basically happening is that you have the GDScript class. The GDScript class reads the GDScript file, and then based on the rules of the language, GDScript, it has these predetermined functions, and these functions are just equivalent to what happens on the notification process for each node when you're doing things with C++. So that class is essentially the class that is going to actually call the function, is GDScript class. So basically what is happening is that the reason why you are able to cache signal connections when you're connecting nodes with GDScript is that you're connecting them through the resource, and then on the saver, the resource saver and resource loader functions, they have logic that allows them to serialize the script instance, which is a member variable of the object. So that's fundamentally the difference between doing from C++ directly and from using GDScript. But what I thought is that is basically the same thing, because if you think about it, the GDScript file is just a class. So the script instance class is the thing that manages the script, and the GDScript class is the class that parses the file and executes the functions at certain points. So what I thought about is that you can do basically the same thing if you create a C++ class, and instead of using the GDScript file, you use the C++ class that you create. But the problem is then how do you serialize? Because the state needs to be transferred to the file, and changing the functionality of the resource saver and the resource loader is kind of annoying because there's a bunch of stuff there. So what I thought about doing is I create a C++ class, and then I create this class in such a way that it allows me to connect any two different nodes of the sync tree, regardless of the order, I think. So, because usually when you connect from C++ directly, you are going to call this function here. So you initialize a class. So yeah, you initialize one pointer for a class and another pointer for the other class that is going to have the callback. So usually the moment you connect the signal, you have to initialize the two different classes that are going to be related to that signal. So in this case, it would be some slider and slider. So I'm connecting the two. But I thought that if and this is the part I'm not 100% sure, but if I store the names of the two different nodes, which is basically what happens on the GDScript there, it finds the node based on the path you put here. So there is a function in C++ that I think is from the sync tree or from the nodes that allow you to pass a path with the name of the node, and then it returns the node that has that name on the sync tree. So if you have the names of the two different nodes that are going to create the connection, and you have the name of the callback function, and you have the name of the signal, and you store that on the C++ class, then what you can do is connect that class directly to the root of the scene, and then you can link, you can listen from the class to events on the root of the scene. But initially I thought the root of the scene, but now I'm thinking more about the sync tree, because the sync tree is the class that has the state for the whole scene, which is different than the root node, because the root node is just the node that is directly connected to the sync tree. So the sync tree is basically the class that manages the whole scene, whatever happens there. So if you can create the C++ class and you can connect you can listen for the events on the sync tree, then every time, for example, that a node is added to the sync tree, you can put some logic that checks to see if both nodes exist, which is basically what's happening on the GDScript here. And then you can construct the signal at the moment that the two nodes are ready. So every time that a node is added, it checks again. And then when both nodes exist on the tree, it connects the signal inside of the C++ class. So it would be like a C++ manager for signals. And the difference, and I think what's better about this as well, is that you only need the names of the two nodes that are going to create the connection, and the function and the signal name. So like it allows you to create signals without having to connect them directly. So for example, the way that I'm imagining now, because what's going to be cached is going to be this information, which is this 4 different string names. The names of the two signals, the name of the signal, and the name of the callback function. So if you create this as, this is the parts of what I have to think now is like, what is the data structure that is the best to keep track of this, all this information here. And the problem with this is that it has to be in a format that it allows you to save on the scene file and load from the zip file, which is limited because it has to be part of the variant class, which is the class that they use on C++ to convert different types. But if you're capable of storing this information on the C++ class and adding as a property, then if I build the scene from the code, it's going to allow me to, using this class, is going to allow me to serialize the names of the nodes and then connect them on the spot based on the state of the scene tree. And also, it allows the possibility of making it easier to connect the nodes from the editor, because all you need is the 2 different node names and the name of the signal. Yeah, the 4 string names that you need there, basically. But if you have those 4 string names, then you don't need to, like, in my opinion, it's a lot more annoying to create the script file and then put the code here. But obviously, the script file is still useful if you're going to use the script. But I think a lot of the times, probably people just use the script file to connect signals. So I think this way is probably going to be easier if I'm able to do it. But there's one big problem with this, which is I'm not 100% sure if I'm going to be able to get the function address for one of the nodes based on the string name. So based on the string name you store on the C++ class, you have to use that somehow to query a class DB and then get the address of the function at the moment that the 2 nodes are on the tree, because you need the address of the function to create the connection of the signal. And that's basically what I'm going to try to do now. And I created the beginning of the classes here. In this class, I thought about using this other class that I created, which is global signal, which is a singleton that I created to be able to emit and connect to signals without having to have the direct connection between nodes. So like sibling nodes can send signals for each other without having to route the signal through the scene tree. So basically what I'm going to be doing with this other class here. The only difference with the other class is that it's going to traverse the scene tree to find the path, but I think it's slightly different because on this one, it's like the coupling happens based on the scope that you pass as an argument here and the name of the signal, so it's slightly different. But I guess I could create a similar logic on this one, but I think it's better to separate the 2. So the way that I could do it on this one probably is by encoding the logic on the scope, for example. So the scope would have the name of the node, for example, and that would allow me to, every time I want to connect signals, I just put the name of the nodes and then I subscribe like that. But I think it's probably better to do it on this other one because you also have to serialize. So I got this from ChatGPT in the beginning of it, and I'm gonna have to spend much time thinking about how to do each thing, then test. But the 2 events that I found that I'm thinking about using now are the events from the scene tree, which is the tree changed and node added. But I think I'm gonna do node added because it seems that it is the best for this kind of stuff because you receive the node. So I'm gonna look for examples here. Then I'm gonna, which I already found this shoe here. And then I'm going to think about this. So I think I'm going to have to use the dictionary because the dictionary, like I said, is the class. It is subscribed on the variant. So there's functionality on the variant that allows you to convert the types. So you can't really use hash map because hash map is more complicated to serialize and deserialize. So I think I'm going to use this dictionary to keep track of the signals, but I'm not really sure the relationship between them. And then on the constructor of this, I get the tree, then I connect the signals. And then I put the functionality, and also I'm going to create the notification function here. Define notification. Puts logic on notification body. I think if this works, it is much better and easier to think about. Because all you need is the node names, so like it becomes possible to set up all the nodes, all the connections at the same time, instead of setting up. If you know the nodes, the names of the nodes you're going to connect. So this is the key thing, though, is that the logic has to be based on whatever is going to be serialized. So I can't make the logic directly connected with the node instances, for example, because the node instances are not going to be serialized. So it has to be something that once the editor gets the state from the scene, the functions are going to work based on whatever was serialized, which is the property of the class. So initially, for example, I was thinking about, like, obviously it's not going to be this way, but like a simple version of this would be, let's say you keep a vector of string names on this class here, which are the nodes that are going to have connections to them. Then if you set the value of this vector and you add this vector as a property, this is going to be serialized automatically, I think, by the save scene functionality, this resource saver. And what that means is that when the editor loads the class, it's going to update the values of the class you have, those names that you put there. And then if you design the function of this class based on those names, then you don't need the address of the nodes, because then it recreates based on the names. So hopefully it's going to work. I'm going to do a little bit of this. So if this doesn't work, which I still think I might do a little bit, but I spent a bunch of time studying the GDScript functionality there, and there's a bunch of code. So I think that going this way of, like if I go more the way of trying to do a bridge between C++ and GDScript approach, or something like that, it seems that it's going to be like a lot more complicated. So I'm trying to avoid this as much as possible and just use C++ if I can. The hardest part is thinking about the addresses, like how to convert the types from the address to the string names. And also, like, the main question that I had was this about how do I make sure that the moment that the nodes are loaded from the scene cache, from the scene file, that I'm gonna have the 2 different nodes in the tree. And yeah, and like be able to make the connection no matter what. But I think that like subscribing to the signals on the scene tree should probably work, I think. And it's not going to cost that much, because the other thing that I was thinking about is like how do people do it with the GDScript? But it seems that most people also, they put the functionality inside of the process. And I think that I was trying to avoid this because it's not very good, because the process runs every frame if you set the process equals true to the class. So obviously you can put conditions there inside the process that check to see whether or not the thing you want to do is gonna happen. But it's not very good, I think. So like it's better if you can avoid doing this. So like putting on the other signals, I think is better if you can, because it avoids calling the thing every frame. It only calls once, or after an event that you expect to happen happens, or that you need to happen happens. Don't remember for this, like this. Yeah. I think this is item. Yeah. Forgot that thing. is object. March changes. Variables. So. Don't remember this one as well, but I think it's something like that. There's two different ones that are very similar. This one might be the one with the slash pattern. I think, yeah, okay. And there's another one that you put slash pattern before, and then you put a string. I forgot which one it is. I'm gonna stop here. So the first thing is to connect. So I'm gonna an example that I have here. I'm just gonna close everything here. So it doesn't get confusing. I could show on the object here. I showed last stream this, like the object has a script instance. It's still kind of confusing to understand. But I found the function, maybe I should show the, like the macros that they use, because that's the part that is confusing. Is another one of the things that they use a Python file, I think, called make virtuals or something like that. That is going to create a file on compile time, and that file is going to be the one that has the logic that makes the bridge between the code on C++ and the code on GDScript. So on several different points you have I think it's GD virtual something. Oh, the notification function is like the same as the GDScript functionality. So like they are one-to-one. So all the parts of the notification that you have are going to be directly correlated with the functions on GDScript, because they run at the same times. So the notification ready, for example, here is equivalent to whatever is going to happen on the underscore ready here. I was going to show this inside of the node class. Let me copy this first. There's a lot of things. It's on the header file. Actually. So yeah, maybe also like searching for the macros here is going to be easier to find the other ones. Their macros, they're defined on the object class. So the object, yeah, object file. So I'm going to search on the object file there, but it's basically these macros here. So these macros are the ones that register GDescript functions. So they're registered as macros, I think, because the file that defines the functionality is generated at the compile time. Yeah, it's basically this file here, which exists is generated by these make virtuals here, I think. Yeah, so this has the code, and this is part of the build system on Godot. So at some point on the build system, they are gonna call this this file here, the functions on this file, and then they're gonna dynamically generate the definition of the functions, which is basically generating this file here. And I think the reason why they do it like this is because of the versioning system. So it becomes easier to change the different versions and maintain backwards compatibility, I think. And basically, these macros here define the functions that are going to be called with another macro at certain points of the cycle. And they're also called on along with the notification, the normal notification from C++ classes. So it's basically equivalent. And the function that actually does the call of the function that is defined on GDescript is going to be this one. So the script instance calls this function, and then depending what kind of script you have, which can either be GDescript or C#, is going to is going to call the callp function for that script. So in GDescript, there's a function called callp, and then that function is going to call another function that is generated based on how they parse the file, which I still haven't went through in depth into it. I think it's GD virtual or something like that on the object file. Yeah, this is the macro that is called on different parts of the rendering cycle, which represent the events that they have there. And this basically just calls the function here that is generated by the other file on compile time. So it's calling this function here, basically, at this function here. Depending, the name is the name of the function here. So for each event, it's just going to call the same macro, which calls that function. And the reason why they do it like this is because these functions are going to be virtual functions, as far as I understand. So like they are defined on the derived classes, which are the instances of the script. But I don't remember really well if there's a connection between, because GDescript, I think it doesn't inherit from anything. So I think script instance is just gonna have the logic that is gonna find the script based on that. Yeah, so here you can see that it's virtual. So maybe I should search for the classes that inherit from this. And there are none. I know there's a connection, but I'm not 100% sure how, because I didn't spend much time. Hey man, what's up? I'm trying to create a system to serialize connection between signals on different nodes on Godot. I think that is the script language. The script language is the one, I did a flowchart on SkyDraw that has a connection. So this is basically the pipeline of what happens after you click attach script. So this is after the GUI is shown. So basically when you go here and click attach script, that's basically what happens there. Before it shows this stuff here, is this part here on the actual C++ code for the editor. And then after you click on create, here is the pipeline here. So basically I wanted to understand the flow of creation of how the GDescript file is created and how it's attached on the object. And it's basically these functions here that get called. Also, the other thing I was going to see is if I change, because there's the language. So can there have GDescript? It doesn't show C# here. Interesting. So maybe for C# I don't have some compiler or something that is needed. But I'm 100% sure that C# is also supported. Not really sure why it's not showing there, but But basically, the way that it works here, at some points, I think that this make template function is the function that initializes the file with the beginning template that shows here. And this function is going to initialize the GDScript class, which is the class that does the compilation for the file. But I'm not. So I guess like there isn't a inheritance connection between them. It's just a connection between the different classes, the way that they work. So the one class is going to initialize the other at some points, or it's gonna, yeah, like there is more composition approach for the connection of these script classes. So basically gets the templates, initialize this, then it sets the path. And then the GDScript class has some functions that they create a token. So I'm going to show there because I think it's interesting as well. But basically the way that I haven't studied too much the other parts besides the parser, where you actually generate the code. But I think the way that it works is that they have several tokens that define the words of the language. So basically the definition of how the GDScript language works. Then they have rule sets, which is the grammar. And then to create the functionality, you traverse the tree that is created based on the rule sets and the words, and then you derive meaning based on the traversal of the tree of what's going to happen. And then I think for actually generating the code, after they parse the code, they use the variant class from Godot to translate the types. And this part is the one that is kind of annoying because there's a bunch of stuff there. So I was basically looking at you here as I was stepping over. So this is the class, and this is the function here that I think gets called there. Whenever you have the macro GD virtual call, the GD virtual underscore call is gonna, and you're using GDScript for that node, is going to call this function here. And the problem here is that I couldn't find this one because I think that this function is defined on runtime, because this function is gonna be based on the way that the GDScript parses the script file. So it parses the file and then it creates the GDScript function class, which is gonna basically is a class that has the state or the logic for creating the function. So it accesses value because it's using a hash map. So this is how it accesses this value here. This one is the key. This one is the value when you use the hash map like this. And then it calls the call function on this thing here. And this one is not defined. I think it's defined on the runtime and is the thing that is going to probably call the logic. So these arguments here are parsed using the variant class with overloaded operators and stuff like that they have on C++. And that's basically going to call the functionality that happens on whatever you put inside of the functions. Hey, what's up? So here, it's very interesting. And then they save this as a resource because this is the part that I don't understand. So like there must be a connection between script instance and the GDScript, because on the object class, it has the member variable is script instance, not GDScript. So there needs to be a connection there. I'm not really sure. It's kind of weird because here is virtual. So maybe they create the class here. Oh, so yeah, they call the function using GDScript call, using script instance call. So it should be this thing here, I think, that they are calling here. And the GD extension is very similar. The logic it happens on the same time on the script instance, but then like it's the same structure of classes and virtual functions and stuff like that. But it's just what thing is going to be connected is different. Just going to be the dynamic linker library you create with the bindings for GD extension, which I haven't studied too much. But I think it's basically the same logic. So it's calling this function here, passing the name of the current function that was executed. Now C++ is the token operator, so it just connects whatever you put here with these other names here. So these names are fixed, and the m name is going to depend on the way that you call the macro, which in this case is going to be process. So here pass the name of the function and then the arguments that the function receive after. Then this just basically replaces process here, for example, instead of here, which means that this function is going to be gd virtual underscore process. So at some points on the process part of the cycle, of the rendering cycle on Godot, they're going to call the other macro, which is gd virtual call, and they're going to pass the process token, and then that macro is just going to call this function here, which is going to call the function from the script instance and the gd extension you have. So it is a virtual function though. That's the thing that's weird. Oh, so this is probably the class. So this is the only class that inherits from script instance. So assuming has should be this class here, the one that actually calls the function. Script instance extension. Score object. So this should have the yeah, this function is the one that gets called there. I think I've seen this before, but I don't remember really well. So it's basically using this native info to call the function. I'm passing the parent. Oh, this is interesting as well. So maybe this is something that I can try to do. But I think I'm going to look for other ways to convert the name of the function into the actual function address, because I think there might be some functionality on the method bind, which is a class that they use to register the functions from the classes to do this kind of conversion. So that's probably the route I'm going to go. But if it doesn't work, I'm going to try this probably as last resource, because it seems here that they are casting the type from string name to this type here, and that does a conversion. Oh, this is GD extension. So this is for the GD extension. So how does the GD script works? So I'm gonna ask GPT see if it says anything useful. And this is very weird. So the main question I have is then how does it translate from script instance to the GD script? Maybe when GD script runs, it's considered as a extension, but that wouldn't make a lot of sense, because I think it's probably more likely that GD script came before. And here on the flow doesn't have anything, I think, related to these classes. So this is the thing that one of the things that I'm trying to clarify as well. So on the object class, which is the class that is going to call these functions, it is a script instance there. So it basically calls on the notification. So it's going to call this function here, which is defined on the GD class macro, which you use on every class you want to register on the class DB. So basically, all the classes that show up on the editor have they call the class macro inside of them, which defines all the other functions there. But the actual function that gets called is one that is going to call this one, which is the notification function. And then inside of the function, they check for the script instance. And then based on that, they call the function from that point. Maybe it's defined on the C++ file. This is basically this one. So this one is the one from the macro that gets called there, which is a recursive function that calls notification for every class on the class hierarchy. And then if you have it calls the notification from script instance. It's not calling copy. It's calling here, yeah, but it's a virtual function. Yeah, so this is the part that is very weird. So I guess I can search for other parts based on the name of the variable, just see if I find anything. Oh, I think it probably creates some inside of the file here. I was just getting the script instance for that file. I think I'm gonna look into this later. I'm just gonna continue there, creating the class. Otherwise, I'm not gonna. So I should probably try to solve everything first, then look into this. But I do want to clarify this. I'm not really sure if it's gonna be worth to spend time trying to clarify how GDScript parses everything. Like the tokens is kind of easy to understand. It just goes over the file and then does the switch statement to check for the patterns, and then based on whatever pattern it is, it has other functions that create the whole token, and it saves the whole token somewhere. But then the parts of where it creates the more complex structures based on the grammar is more complicated, and also it's kind of harder to understand. And also the parts where it uses those structures to generate the code based on the variant is also kind of confusing. So I'm not really sure if I'm going to spend time studying them. But this one has been annoying me, so I do want to understand how this works, but it's not very clear how to create a connection there because I can't find it doesn't make any sense. Because if this is a virtual class, then there should be an instance there. So the only thing that would make sense, that I think now, is that the class that derives from this is created somehow on runtime. It might be like as a byproduct of the parsing process, which is basically the same logic for the function there. That like the function is not called directly from GDScript, it's called from here. And this thing is generated on runtime. So it might be something like that but yeah, that would be Because I guess it's gonna depend on the way that like the path from the file to the script instance, I think. So I think, and this is the part that I want to clarify more, but I think what happens there is that when you attach the script to a node, then, and this is kind of the problem because you can only know from the editor there unless I go manually through the code to see how if the engine does it in the same way. But from the editor's point of view, you after you attach the node, the script to the node is going to use the GDScript class directly, and then probably after you use the GDScript class to parse the file, that's probably when it creates the class that inherits from script instance. But even then, it's kind of weird to I think about it this way. So many files. Or it might be because of this. I think GDScript inherits from script. I don't remember actually. Maybe not. I think it doesn't inherit from anything. Oh, so it does inherit from script. So maybe that's how the bridge is done between the two. The script instance has script class. It's very confusing, not gonna lie. Like, it doesn't feel. It feels that there must be something that can be improved here, but like it would be too much work, I think. So let me. So I'm gonna focus on trying to create this class, and then if I can do it, then maybe later I will try to understand the connection there. I'm just gonna copy this stuff here. Hey, thank you. missing main node. So I'm thinking I should probably create here. I think it's not showing probably because I didn't compile this. I'm gonna remove this. So I'm probably gonna do it from here and also from after connecting with the sync tree. I think that's what makes the most sense. Yeah, so for the connection, I'm gonna do the string names, I think. But the main thing that I have to clarify is whether or not I'm able to do the... So I think it's probably better. You can also use vectors to serialize. So the classes that you can serialize are based on the variant class. So the variant class is the main class that is used as a bridge between both like script and everything. Like whenever you need to translate types in different places, you use the variant. So it is possible to create other types to be able to use variant with them, but it's a lot of work and it's not... Usually it doesn't make sense because you can... It's much easier to just create a type that inherits from object and then use object as a type you're specifying. In the case I was trying to create bar set, for example, I was trying to create a struct to name bar set parameters, and then it didn't work to emit signals with that because it wasn't registered on the variant class. But then what you can do is just inherit from object, and then whenever you want to use bar set, you just specify object instead, and then it is able to figure out because using a pointer here. So the variant class is going to store the memory. It's going to store the pointer or the memory, depending on what kind of thing you have here, on itself, and then it's going to be able to do the translation based on the type because it overloads all these operators here. So you can use these kinds of vectors here as well, and you can use a vector 2, vector 3, and so on. So I think that the main ones that they're probably the best to use is dictionary and vector. Maybe I can try to use the callable as well if I can. But I'm not really sure if the callable is... I think that... maybe it is... I think actually it is serializable. So I'm going to write this down. So the way that you serialize, I think, as far as I understand, is you call the add property macro. And the add property macro is going to call some functions from class DB, which are going to register the properties of that class on the registration system, which is basically class DB. And when you save the resource, the resource saver class is gonna get the properties from the class DB for that class, and then it's gonna write to the sync file based on the properties. So the class that it holds the information for the property is property info class, which is created through the add property macro. Then on the loop where it's saving the sync file is gonna get the properties with the functions from class DB, which is get property list, I think. And then it's going to loop over the properties, and for each one, depending on how you created the property info, is going to write to the sync file here in different formats. So, like the script is probably resource, and then that's in a specific case where it saves in a different way, and the other member variables is just writing the state of the variable at the moment you saved. And then on the load, it's going to be the same thing, where it's going to read the strings here, and then it's going to convert that into properties, and then it's able to update the object based on the information here. Oh, this is interesting as well. This is another thing that I didn't do the first time. So the first time that I did the workflow there, I went with what happens after the attached script, but I didn't check to see what happens after you click on the connect here, which is the flow that I did this time. And it seems that if you do it through this, it does cache here. But obviously it's going to cache using the script file, which I think is not the best. But maybe I could look into this as well. If what I'm trying to do now doesn't work, I can look into this and try to do an approach similar to this. The most annoying part is figuring out how to change, because this approach requires you to change the way that they load and save resources, which is kind of annoying to do. That's why I'm trying to avoid that approach and trying to use this other one. I'm gonna look for callable. So for examples of add property that use callable. Well, I think I wrote a spreadsheet with the different types, but I don't remember. I think I probably didn't write for callable because I was looking more for objects. So callable string name, vector, string name, dictionary. I think those are the main ones probably that I'm gonna use. So I need to think about what is the best way to use these data structures here to store the information, which is basically these 4 different names here. And what I'm gonna do is just based on the names and on the points, I find the node based on the name on the scene tree. Find the 2 nodes. If the 2 nodes exist, then get the node. Then call the connect function for the node based on the name of the signal, pass the name of the signal based on the way that it's stored there, and also get the target and the function name. So based on the string name for the function, I have to see if I can get the function name. Which is, I think this part is the hardest, but if I can store the callable, it's gonna be easier, I think. Or maybe it's the same thing. I can implement the 2 approaches as well. Because basically I'm gonna set these things on a function from the class there. That's how I'm thinking about doing. Yeah, so I think if I'm able to do it based on the callable and serialize the callable, I think it's easier probably. Because then I can do it, I can call the function from the other class, this class here, at the moment that I create a callable for whatever class I want to have the callback function. So this. I should return an error. I think I should try to compile now so that this, let's see if there's anything wrong. And then I do it later, rest. I also, let me think about this. So probably I don't need the serialize and deserialize. I'm just gonna let's here, because it's gonna be serialized based on the property. So the connect and disconnect are gonna be the ones that's so I'm gonna need another one which is gonna be to update. So on the update I call the connect. So the connect has to be like receives the info needed, converts the info to create the connection. No, I think that it doesn't have to convert. Yeah, because the important thing is that the function that is actually gonna create a connection has to be one that can be based on the serialization. So receives and updates member variables with information needed. Then function that creates an action. I'm not going to do on the constructor. I'm going to do when the node is ready. So this notification ready here is the one for this node, but here yeah, so here I connect to the sync tree, and then I call the function that I'm gonna define here, which is gonna be the one that updates that creates a connection based on the state of this thing here, this class here. So this class is directly connected to the root and is always listening for the signals on the sync tree. So whenever nodes are added, it runs a function which checks to see if the two nodes exist, if there is a connection and if the two nodes exist. And if they do, then it converts the information from the class, which is the information that was serialized, into an actual connection between the nodes. And I also do the same on the ready, in case the class already starts with the thing. But maybe it doesn't make sense actually to do on the ready, because even in the case where the state's being loaded from the sync cache, this class has to wait for the two nodes to exist. And the only reason why I'm not, I try to look for a signal that is only emitted after the whole sync tree is done, but it looks like it doesn't have, like this signal doesn't exist. So it has to be, I have to check each time that a child is added. But I don't think that's very problematic, because if you put the if condition there, then it just returns and doesn't do anything. So I think it should probably be fine. So let me think. So let me look for examples with the add property that use callable. Okay, so there are. So maybe I can use the callable. I think I'm gonna try to implement both. But if I can use the callable, it's a lot easier. So what you have to do to implement is just create a setter and getter, and then specify these things here. But I'm just gonna copy the way that I have here. And this is gonna automatically make Godot serialize the property, because that's how the resource saver works. So this one is gonna add the property info class to class DB. So get class static is a class that is defined on the macro, the GD class macro, and is the one that is going to return the name of the class, which is the type of the class. So for example, if I have node 3D, get class static returns node 3D. If you have node, returns node. The M property is the property you pass there, which is the property info class. And then the setter and getter, the names of the functions. So this is just going to register that property info class on the class DB. And class DB is the class that they use to keep track of all the types. So this gets the type of the class. So this class info is the class that contains the information that allows them to retrieve the methods and the properties of the class based on the type. And they're basically saving here as part of the property list. Then when you call resource saver save or resource loader load, is gonna call a function that is gonna loop over this property list from the class info, and it's gonna retrieve the property infos. So maybe this is a approach that I can see if the callable doesn't work, because it's basically the same thing that they are doing here. And I think I can copy the way that they do here, because at one moment they're gonna have to translate the string that they use to specify the function name into the actual function. So I think I can use the same logic there. It should be possible. So like here they only put the names as a string name, and then they have to convert from this to the actual address, which is exactly what I want to do. But I'm going to try with the callable first, because it seems easier. It has to be on the bind methods. So I have to think about a name for the property and then put setters and getters, which is very easy to do. Obviously, I can copy the way that they do here, but it's very easy. Yeah, callable and then just return. I think it should be public. And then the thing is private, the properties. So let me think about a name for this. Oh, it can't be callable actually. It has to be. Maybe this is going to be a problem actually, because that should be a vector of callables. Yeah, I think I'm not going to be able to do it with the callable. So it's probably going to be strings. Because the thing is, so this is the main thing. I'm going to spend some time thinking now, because this is the main thing that is kind of confusing to think about. Because obviously there's a bunch of different ways to connect the information. So the first way that I was thinking is just two hashes, for example, or two dictionaries. So one dictionary connects the target, the source nodes with the target, and then the other one would I would need probably two more. Because the source has to be a list, I think. Like it has to connect at some point with a list. So like the source has a signal, and then for each signal there needs to be a list of connections, of callbacks. Because obviously more than one class can connect to that one. Maybe you should do the sync reconnection first and set everything up, and then I think about this. The problem is that I'm like, yeah, I think because it has to be a vector of callables. The property I'm going to subscribe there, but maybe actually, no, but then like I was gonna say maybe I can use another variable that is not cached that holds the callables, but I still need, like, it doesn't matter. It's gonna be the same thing basically. Now what matters is the properties that are cached that I have to think about, because those are going to be the ones that are the entry points for recreating the information. So I think probably on the connection is going to be, maybe these ones are going to be like fixed. So string name, source nodes. I'm going to do on the same order that you call the connect function. The signal name. So it's source, then you call the source calls connect, then it passes the signal name, and then it passes a callable. Callable MP, which is a macro that creates a callable from another callable. And the callable is the class that holds the state for the function and the object. So it holds the instance of the object and the function pointer. And then when you call emit signal, it's going to use variants to translate the types, and it's going to call the function from that instance that you pass there. So here would be targets connection node. It's probably going to be node's name. I'm going to do it based on the node's name. And then function target function name. So I think it's gonna be the endpoints are gonna be these ones. Then I have to figure out how to translate. So And then it's going to be automatically cached. So I think that's basically, because the other one is the one that is going to create based on the information. So let me think about the name. I should think about a name for this function, which the purpose is going to be to use the member verb, the properties of the class to create the connection from the nodes. So maybe the name of this one should be different. Maybe just put update. I'm gonna leave like update, then I'll think about this later. Tough. Updates. Yeah, so this one. I think this step here is the hardest. Yeah, so before I think about this one, I have to think about what is the best way to structure this. So I'm gonna let's see if I can compile like this. And then think about how to structure the data. I think before I do this, I'm going to try to compile. I'm going to see if I can, like, already search the examples are, so I'm going to copy the examples of the connections here. I will probably put node edit. I'm going to copy these ones the way that they do it. So get tree, then you connect the signal, then put the callback here. So the way that it's going to work is that I'm going to use this class here. So every time that, so initially, which is what I'm trying to do now, which is study the editor layout. So if this works, what I'm going to do is just copy the editor code to create the layouts. And instead of using the connect, whenever they use the connect signal, I'm just going to use that class there. So I'm going to always initialize the class in the beginning and put directly connected at the root node. And then I'm going to be able to, if it works, I'm going to be able to see how the editor layout works. And this is going to create the whole thing from code. And I think that the main difference is that like you can't really create only one class. You can, but if you do that and you put everything on the constructor, then it's not going to show on the editor. Because I'm pretty sure that the editor separates the nodes based on whether or not they were created inside of the constructor or not. But this might be another thing that I can try as well, but I'm not really sure if it's better, which is to just create a function instead of a class. It's another approach that I was thinking about. So you create a node that is going to be like the standard root you always use for the scene, and that node just inherits from node. So it would be like a root node, for example, which inherits from node, and then on that root node you define a function that adds the children. So that way you add outside of the constructor. And if that works, then it would be like a similar logic, I think. Serial name, connection. So now I think that I'm gonna try to, I have to close this. It's object. I'm gonna try to, and maybe it's this one that I don't need. I copied this one because it wasn't giving the type here, or maybe it's not needed. And I'm putting this class as part of the core object because I think it makes more sense than to put it as a module. I'm just gonna close everything. It's easier to think about. And any resource for learning C++. I learned initially from Code Academy, so they have a free course that's very good. But I don't, oh, there's also, I don't remember exactly the sites, but there is a video on my stream where I was trying to learn from two different, so there's one book, the best book probably is Pointers by Ken something. I think I have the name here. So that book is very good. The other, there's another YouTube channel that's very good, which is, I always forget the name of the guy. I think it's C++ Weekly with Jason Turner. Yeah. So Jason Turner's channel is very good. And Pointers by Ken Riff. And also there's two different sites, I think, that have some pointers exercises, which are very good, I think. So it's basically this channel here, very good. And I think this live stream here, this live stream is probably the one that I was doing the exercises on pointers. Let me see if I can find A Kenneth Rick pointer. So this is the book. So search for this guy here, Kenneth Rick pointers. Yeah, it's kind of harder to, because more people want to learn web dev, right? So it's harder to find. But I think only this resources is already enough. And there's a bunch of different books, but I didn't like most of them. I think Kenneth Rick is probably the best because it's hard to. And maybe if I read them after like doing stuff, but I think it was too much because in the beginning, so like you need more reference frames of building stuff for those books to be useful probably. The other books on C++. I think in the beginning, the most important thing is the fundamentals, I think. So, and probably the most confusing part is going to be pointers. Pointers and types, I think, is probably the hardest in the beginning. But it's kind of hard to know as well because like now you lose kind of the reference frame you had when you started. And I didn't start learning programming with C++. So I already knew some stuff before. So maybe this is needed. Yeah, it's very different, but it's very similar. So C is based on functions, and C++ is based on objects. So the biggest difference between C++ and C is that on C++ you have the standard library, and the standard library has types that do stuff that's on C you have to do manually, which is basically allocate memory for an array, for example, and also for dealing with strings. So usually on C++ you're going to use a class that already has the functionality inside of the class that is going to deal with all the stuff you would have to do on C, which is allocate memory. And also the other difference is going to be the inheritance, which is very complicated. But for learning inheritance, I think it's much better to search for a project and then look into the source code of the project. So find a project that you think might be interesting and then look into the source code directly. And then you're going to have a bunch of questions. So like after you learn the fundamentals, the basics, look for the source code, then you're going to have a bunch of questions, write down all the questions, then use AI, like ChatGPT or Claude or whatever large language model you have access, and use the search engine, obviously. And then as you clarify the questions, it becomes, because it's better when you have the context of like something you want to learn how to use. But in the beginning, it's going to be overwhelming because you don't know anything. But yeah, like it's better to explore based on whatever you want to actually do. In the very beginning, it's better to like get the fundamentals right. So we learn about pointers and about grammar. Grammar is also, I think, it's not very important, but it is. Like one that I always recommend to people is to watch Ben Eater's series. It's probably the best thing in the very beginning. Because the most confusing part to understand the beginning is how the computer remembers. But it depends on like how fast you need to learn and stuff like that. But this series here is probably the best. Just basically the SR latch gate and variations of SR latch are the gates that are used to actually store memory, random access memory, and then the hard disk memory is done with magnets, with disks. I think that it writes on the disk and is able to stay for longer, but it is lower. Oh, no worries, man. No problem. It's tough as well in the beginning. And I think everyone probably is going to struggle with that, but it's worth it, I think. That people don't have the incentive to create content that explains the stuff that actually matters, like in practice, because it's too hard. It should nuance. It should should depend on the actual application or whatever you're building, and it is also too complex, and most people don't watch. So there is like lack of incentives to create that kind of content. So like the way that it's gonna go usually for people is that like in the very beginning you're gonna have a lot of resources that teach like the syntax, but they're not gonna give context of like what it means for the syntax to do something. And this is the part that is the hardest and the part that you have to focus most on, in my opinion. And in order to clarify that, the most important thing you can study is keywords related to compilers. So compilation process is very important, and the memory, understand the memory. Because learning programming is basically clarifying how abstractions are made, and abstractions are the keywords of languages. So, and also like how does the hardware make sense of the abstractions. So the connection between the hardware, the bits on the hardware that create the logic gates, and how that connects with the symbols you write on the file. This pathway is learning programming basically. And then after that, all that is happening is just variations of the same thing. Just like different languages, it's just different ways to build abstraction based on the logic gates on the hardware. And the series is probably the best, the 8-bit bread computer, to understand how everything is connected. Like it's obviously just a conceptual level, it's not practical because the actual hardware is going to be more complex, but I think it's enough probably. Nice. I'm working on, so there's this thing. Obviously, I assume that you don't have experience on C++ because you just learned. So you're just asking how to learn. So like, usually the main thing that people do with C++ is to develop games. So we have something called a game engine. And a game engine is just a connection of code. It's just a bunch of code that people developed to be able to make it easier for you to create applications. So the main ones that exist now are Unreal Engine, Unity, and Godot. And Godot's the only one that is fully open source. So it's basically, so the code that I'm looking at here is the source code that creates this executable here, which is the Godot engine. And what it does is just basically communicates with the operational system, which communicates with the hardware in order to allow you to draw stuff on the screen. That's basically what the application is. So the code there, the source code creates the GUI. And this application allows you to create games, basically games and applications using this. So the name of this is the editor from the thing, which I'm also looking at the source code of the editor there. So there's the editor, which is the GUI application, which is built on top of the engine, which is a collection of codes that allows you to draw stuff on the screen. Yeah, so what I'm doing is I'm changing the source code so that the stuff that I want to do, that I can do the stuff that I want to do. So what I'm trying to do now is basically create a sync from source code using C++, and also being able to change the sync from the editor. And right now you can't really do that, because if you do it from, as far as I understand now, there might be ways, but I couldn't find any anyway. So the way that people usually do it is they use the GUI here to add the nodes and stuff like that. And then they use this other language called GDScript, which allows them to encode behavior on the different nodes by whatever code you put here. But what I'm trying to do is do everything from C++ and also be able to set up all the nodes in the beginning, or like for whatever reason that I want, from C++ code. So I spend a bunch of time studying the source code, and I'm changing the source code, so I'm able to do this. And then after I do this, I'm probably gonna try to create applications or games or whatever, like using the stuff that I'm developing now. And now, like specifically now, I'm trying to create something that allows me to cache the connection between nodes. But that's gonna be like a lot harder for you to understand, because like you have to understand how the engine works. But basically, from here you can connect the behavior of two different nodes using this thing called signal, which is basically allows you to set up an event. So like when a node, for example, moves, you want the other node to do something, you would do that by using a signal. So it allows you to create a link of functionality between two different places. And the only way to do this, as far as I know now, is by using a script, using the Godot script and setting up on the editor. But I'm trying to do this from C++ code, and there isn't a way, as far as I know right now, to cache the connection on from code. So I'm trying to create a class that is going to allow me to do this, so I can build everything from C++ code. I have to probably. So this is the thing. This has to inherit from nodes, I think. This is not. That's the reason why it's not showing that there. So maybe I don't need. Yeah, I'm gonna try it. Sure. So I'm probably gonna have to replace one of the includes there. So yeah. But I'm gonna try to compile like this then. Should be. Maybe this makes more sense. Yo, thank you, man. No worries. It really depends on the day whether or not I want to. Some days I don't want to talk. But that's how I've been doing, and like, so far. And sometimes I put no chats there because I'm trying to be more focused. But whenever I don't put that, or yeah, there's some days that obviously doesn't matter that much to talk because I'm not that focused. Then some other times I might not answer anything because I'm trying to focus on what I'm doing. I should close this. So it might be because I don't have string name here. But usually this kind of this error here, when it says from the variant the binder common, and actually when it shows this thing here, it's usually going to be something related to the variant, because the way that the variant works is that they create a bunch of structs that help the help implement the functionality that is going to convert one type to the other. So usually when I see this, it's something related to the registration system. But I'm not 100% sure what it is here, but I think it's probably something to do with the string name. So maybe I'm gonna try like this first. So I'm gonna try to, I think score, but I forgot the full path. String. So I think that it is complaining because of the registration here, because at some point try to convert. This one is kind of weird that I remember, because this one, it only returns the thing. So it has this spread operator and then it returns this. So I assume what's happening is that it's putting like everything on the same string, the name of the function and the name of the arguments that you put here. And I just do this pattern based on the other examples that I've seen from them. And then this one is going to connect, is going to use this templated function, just uses variants to convert types in order to register the function and the arguments on the class DB. So they use this method bind here to hold the state of the function. So this is the function address you pass there. So they create this and then they create the register on the class DB. Instance type, yeah, class DB. Whatever. It might be something else. So it might be because the variant doesn't have an address. I can either do const and then the thing there, but I'm not really sure if it's the best. Because I'm probably gonna... I'm not really sure if I'm gonna change, actually. I'm just gonna remove and try like this. If this doesn't work, then I try... Either I look for another example where they use string name, or I try with the const. How do you like keep track of what it does in your mind? Because in small systems is very easy. We got tens of thousands of lines of code and stuff. It is definitely more difficult. And I feel that sometimes as well. But it's just a matter of habits, I think. Like in the beginning, it's very overwhelming because you don't know anything. So like the beginning is always the most, like the hardest. But over time, what happens is that the more you study, you start to memorize the different functions, and then it opens up space for you to know the other functions. Because then, so for example, let me think about, the connect is an example. These are the class B bind methods. So like if you don't know anything about Godot and you see this bind method here, it's going to be very confusing because there's a bunch of other stuff happening. But then, like, let's say you spend one day just studying bind methods here, and you go really in depth into this whole class and everything. Then over time, what starts to happen is that next time that you see the bind methods, you already have a good idea of how it works in your mind. And then gradually you start to learn how everything works. And I think like this is just a natural process of learning everything. It's just that your subconscious mind expects you to know everything instantaneously because of the internet. Because when you look at someone that is good at what they do, you don't see like all the effort that they put to get to that place, which is just like block by block. And there's a natural tendency for you to not want to spend energy and take risk. So like your body is designed so that you don't take risk and you save energy. And what that means is that you're always going to look for unrealistic expectations, so you don't have to put in the work. So in your mind, subconsciously projects you into the future, like, and calculates how much work is going to take you for you to know everything. And then it starts creating ideas for you that rationalize not doing anything because it's going to take forever. But then paradoxically, if you don't do anything, it ends up taking a lot more work because you're living life avoiding doing the work you know you should be doing. And that's how usually, like, the default behavior is going to be that if you don't have awareness. And then whether or not you do the work is going to depend on what you value at the moment in time. So usually there's going to be this battle in your mind. So the way to overcome that is to bring awareness to that and to break down the problem into sub-problems so that you can focus on small steps and then think about like reframing your mind that every time that you learn something, it's going to become easier and easier, and that's going to pick up momentum over time because then it's going to start working for you, not against you, because you're going to download all the data into your subconscious mind. So, and that's the reason why it looks easy from the outside. Whenever you see someone that is good at what they're doing, it always looks easier than it actually is, like actually doing the thing. Because they spend thousands of hours memorizing everything. Like in any sport, anything you're going to see, it's always going to be the same pattern. And it's usually going to follow a ratio, or most people, they're going to have unrealistic expectations of what it looks like for them to do something because they're comparing themselves with someone that is already very good. So, and they also are trying to avoid doing the work. Yes, it gradually builds up. Like the key is to always reframe in your mind and understand that like every mistake you make and every the pain you feel for learning the thing makes it easier and easier over time the more you learn it. Because, and like this is the thing, is because your subconscious mind is always going to try to make it seem for you that you're always going to be like, it's always going to be this hard to learn. And this is what stops people from learning because and what your subconscious mind is trying to do is trying to make you save energy and minimize risk. That's why it's doing what it's doing. Like it's trying to protect you from spending too much energy into something that is not very important to you. So it's like a test to see if you really value the thing that you're trying to learn. But if that's actually important to you, then you have to reframe in your mind and understand that like it's gonna reach. It's not always gonna be very difficult. It's gonna get easier and easier every time. And the faster it becomes easier is the more exposure you have to the pain and the more frequent the exposure is. Because then eventually everything becomes automatic and then it creates a virtuous positive cycle. Because every time that you go through that loop, you're going to have the reference frame of having something very painful that happened and overcoming that, and then realizing that it became easier after you overcame, and then the next cycle is going to become easier because you have that reference frame. So it's going to build up over time. So, and this is basically how like automation works and everything. until eventually you reach. So in the beginning, it's very hard and looks like nothing is happening. But then we reaches a certain threshold where you know everything because you spend a bunch of time. So like all the commands, everything is gonna feel natural to you because you already know. You build on top of. But it really depends on like your value and what do you want to achieve. What do you value and what do you want to achieve? So now I think I'm going to search for this. It makes more sense to put on the ready instead of the constructor, I think, as well. So one of the questions is, should I create another function? So I'm not really sure if updates the best name as well. Oh, don't worry. So I'm contemplating on whether or not to separate into two different functions and whether or not to change the name there. Because obviously I can put the logic on the same function, then just check, just say. But I think it probably makes more sense and is easier to separate like they did there. Because then, yeah, that makes a lot more sense because like the arguments that this function receives are going to be forced to be the same here. So maybe I change this to subscribe and this to unsubscribe. And then I put this as connect. Or create connection. Yeah, so I think I'm gonna do that. So this makes more sense. This subscribe and unsubscribe. Subscribe. Maybe I'm just gonna put connect and disconnect. Alright, it's actually connect. Let's connect. maybe we should put enter tree instead of ready, because I think notification enter tree is going to guarantee that the signals are connected before any other node. I'm not really sure about the ready, because I haven't spent too much time looking into the cycle as well to like have a clear vision of how like what is the steps. But I'm pretty sure the enter tree happens before the notification ready, and I think that's because I'm pretty sure about that because of the graph 3D that I was working on. That when I was putting the functionality inside of the enter tree, it's lower on the editor to start, but when I put on the ready, it's after. So I think the way that works is that the ready happens after everything is ready. So after it sets up the scene states, I think, and the enter tree happens right after the node is on the tree. And I think that this is the reason why I wrote down here on all the stuff here, because the names are different. So it's kind of if you try to search for the name of the signal, you're not going to find, because on a lot of them it depends on the states there. So they do it based on the variables. But let me look into the thing is that these events are not the I can look based on the scene tree there. Oh no, but the ready is actually so the ready happens on the propagate ready of the node class. So it happens here, and this is gonna happen some point on the rendering cycle that I'm not really sure. I guess I can look here. So, so it probably happens in the very beginning. It happens after initializes the main loop. This is probably recursive. Oh, this one is not recursive. I think it depends for each one. But I'm gonna ask ChatGPT. I'm pretty sure that the enter tree happens first. Yeah, so I guess this is the thing that I was thinking about before, that I said about creating a new class inherit from node and then always making that class as the root. I think that it might be better, because then you can put the functionality on the ready only, and then you would call because that would make sure that whenever you set up the signals, that the two nodes are always going to exist for the connections. The problem with doing the way that I'm doing now is that I have to check after each node is added to the scene. I have to check, and then it's very likely that a lot of situations one of the nodes is not going to exist, which means that the function is going to be called more times than initial. But the problem with this one is that I think if I can, maybe I should try that. If I can add the nodes and see them as separate nodes on the editor, then I think it's probably better. Because I haven't tested yet what happens if I... Yeah, maybe I should do that, actually. I think I'm going to set up like this before, and then if it works, I'm going to try to change the name of the class to sing root, or to root node. And then I'm just going to inherit from node. I'm already inheriting from node there, so I'm just going to change to root node. And then I'm just going to switch the events so that I do everything on the ready. And then I don't do anything on the constructor of that node, and I add all the other nodes as children of that node outside of the constructor. That's probably better, actually. So it calls the notification first, and then it emits the signal like this. And I'm pretty sure that the scene tree is gonna, the add nodes, node edit is gonna call with, is gonna pass nodes as an argument. So let me look into this one. So this function are gonna have to node removed, I didn't see. It's probably gonna receive the node as well. Yeah. Okay, so now I have to spend a bunch of time thinking about what to do. And the question is on the subscribe here. So I have to think about what data structure to use to convert. So I'm pretty confident now that it's possible to convert the string name into the function address, because that's how that property works. I forgot that that property subscribes things just with the name of the function. I remember the bind methods, but the bind methods is kind of weird because of the macro that you usually use there. It looks like they don't use macros here. Yeah, but the function is more complicated. I think that property example is easier to think about. I'm looking into the, oh no, I looked into the correct one. So I'm gonna do subscribe first, and then I already have the example using callable. So let me think about different ways to structure the information here. Use properties of class to create signal connection between nodes. Just gonna get node based on the path, track the axis. Oh no, this is the connect. Whatever. let me think about this. Yeah, because on here, I'm just gonna store. So the information, the way that I decide the store information here is gonna impact the other one. Let me. So obviously I can use a dictionary to. So let me think about this. So for each source, there's gonna be like one signal at a time. Maybe I can use scalar draw to clarify because there's different ways to do it. I think that the signals are less for each node. Because obviously there can be a bunch. I think it has to, like, the logic has to start from the source. It has to be based on the source, because that makes more sense. Because obviously you need to see, in order to be able to connect, you need to get the source first. So I think I check the source first, and then check the target. But obviously you need both anyway, so it doesn't matter that much. But I think it makes more sense to think about it from the source perspective. So for each source, you have a bunch of signals, and then for each signal, you can have a bunch of nodes, a bunch of callback functions from different nodes. So the callback function from the target node is a one-to-one connection. So it could be like a dictionary connecting targets, connection nodes name to target function name. And then I look it up based on the and this is the thing, because the source can have, like, there can be multiple different signals for, like, one source can connect multiple times. One source connects. Now for the same signal, there can be multiple connections from different targets. So same signal can have multiple connections. And the same source has different nodes. I'm gonna draw on SkyDraw, I think. Should clarify my mind. The source name. So each source has multiple signals. And for each signal, you can have multiple targets. I think a hash, like a dictionary of a dictionary, makes sense for me. But I'm not really sure if it is the best. Because the signals are always going to be the same. Actually, not. It depends on the class, the target class. I think the signals vary less than the amount of classes that are going to be connected. So signals is more static. And then for each one of these, there is a there can be a source, a target node. Then each target has only one callback function. I guess it comes down to the thing is, I don't think it matters that much which one varies more. But the targets have a higher variance, I think, than the signals, obviously. Because the class is usually going to be roughly the same amount of signals. And probably it's going to follow the 80-20 rule, where some of the signals are called most often, depending on what class it is. So for a button, for example, the pass is the one that's probably called the most. So maybe it makes sense to do it like this. Like one example, like the easiest one that comes to mind, is just a dictionary that connects a vector. So I have like 2 different dictionaries, but you would need 3 different data structures. I'm trying to think about what is the best, like least amounts of data structures. Because I think that the more you have, the more chances of failure, I think. It's better to couple everything. The thing is, I haven't spent too much time studying the dictionary as well, so I don't know how it works. But I think like the simplest example comes to mind is the dictionary connects the source with signals with the names. These are like questions like what methods can I use from class B to get the information? Because that's going to influence how I should do it. I can check based on the source what signals does the source have. So for example, on the connect function there, so like the way that I'm thinking about doing is, since I'm going to build the stuff from code, it doesn't matter that much, like, because like obviously you still can add normal nodes from the editor if you want. So I think it doesn't matter if this is only used for this situation where you build the scene from the code and then it loads the state based on the cached values of the class. So if that's the case, then I can make based on the after the node is added. So this would be the source node. I forgot to put the thing as a argument here. So from the source, I can maybe I can call a function that checks to see, like maybe I can check to see if the source has the signal. First, I need to check if the source exists. The thing is, I can store, yeah, so I'll probably get by name. Yeah, so from the source node, you get the name. And then based on the name, you check on the class to see if there is any signals. And then if there is a signal, if the class name exists, it will be this value. And maybe I can get all the signals for the name using some function from the class B or something. But I still need to start a specific signal, so it doesn't matter. So maybe this way, so like dictionary. So the first dictionary would connect the node names with their signals, and then there would be another dictionary that connects to a vector. So I have to see if that's possible. I don't think. I have to see if that's possible. Because I would have another dictionary that maps the key is the name of the signal, and the value is a vector of the nodes of the names of the targets. And from the name of the target, I would get the node using searching by the name of the tree, get the actual object. And then from that, I get another function, which is the name, another dictionary that would connect the name of the target with the name of the function. But I would have to be a vector as well. Because if I use a dictionary, because obviously there's only one key for each value. So yeah, it should be. So I have to see. Let's ask GPT because this is. I need to spend some time studying this dictionary class. I already spent a little bit of time, but not that much. Well, it works based on variance, so it should be possible to have the value as a vector of string names. The only problem with this approach that I'm not sure, and I'm trying to think about it a different way, is that it requires 3 different dictionaries, which is not very good. So I'm trying to see if it is possible to, or if there's a better way to connect with less data. I think it didn't understand what I was talking about. Yeah. So let me think. You just have to spend some time thinking. As a, I'm pretty sure that you can cache the dictionary because it's a variant. So using dictionary should work, and using vector or string name should work. So all these types should work. I think this connection should probably work, but I'm not really sure if it's the best way. So I guess another way would be to connect the source with the target. But then it would be like the same, I think. Because if the source, you have to be at least a vector of targets. Or I can have vectors, one with the source, another one with the targets. And then I connect based on whatever node receives. So I have a dictionary with the source mapping to signals. Yeah, but it's the same thing, I think. So I do think I need 3. So one dictionary maps the name of the node with the signals that were subscribed for that node. The other one maps the target name with the function callbacks, and the other one bridges the two. Maybe we should ask ChatGPT as well to see what it thinks. I think the thing is, like, I'm gonna, but I need the name to check, just so. Maybe I don't need to store the source name. If I do it like this, because I already have the source. Yeah, I think I don't need the source name. I just need to store the target name, because I received the source. And so for each source that I receive, I just need to check to see if the target name. But then how would I know? Yeah, I need a source name, because there's no way to know. So I'm gonna try to implement the easiest approach possible. I'll do this one, and then I'll think about this. There's gonna be a dictionary, the maps. Things not templated. Yeah. I think that this wouldn't work. Because obviously, I wouldn't be able to know. Because the classes are gonna have the same signals. So it makes more sense to map the source to the target in the first dictionary. And then figure out the signal. Yeah, because the source to the target, it doesn't matter how many signals that were subscribed. So source to target. And the problem is that for each one of these connections, I need a vector of the signals with the functions. So this would map the name of the source with the signals that it has. And the other one is simple because it is the target true function name. Yeah, but let me take a look at this. Because I have to see which function is related to each signal. Now, this is actually more complicated than I thought. It's confusing because of the order of dependency. Maybe I'll take a break now. I'm contemplating whether to take a break or stop. Because I have to spend time thinking about what is the best way. I'm not sure if I can do dictionaries of dictionaries as well. But maybe it's better to avoid doing this and link them separately. So I can view the target name and the function name as one thing. Oh, but that doesn't make sense. Because each target has multiple functions. Maybe the function to the signal. But it can be a problem. Unless it's, but even if it is a vector, it's not very good. I have source signal. The problem is that one target can have many functions. There is always gonna be like one-to-one the signal and the function from the target. I can't really use signal as a key because multiple nodes are gonna have the same signals. So signal has to be a value of something. Or maybe I can, but then like make the logic depend on the other values. Because even though they're gonna have this, multiple signals are gonna have the same name, I can filter based on the connection of the source and target. So if I map source to target, I think I can map source to, I can map, like, it doesn't need to be source or target. It can be node name, because obviously, like, it doesn't matter. Choose signal. But then I can't use the signal. I think I'm gonna stop here because I have to spend a bunch of time thinking about this to see. It's not very obvious, even an easy way, because you have to think about, like, the difficult thing is that you have to think about all the possible connections and the difference in connections you're gonna have. But I think like the rest is pretty clear if it works. So the two challenging parts about this is figuring out what is the best data structure to organize this based on these string names here. So I can have the states stored on the class. And then the other is going to be how to convert the string name into a function. But I'm pretty sure now that it's possible to do that because of that property thing there. So if I can do, like, the other ones I think are going to be a lot easier, which is to convert the string name into the node and convert the node into the name. To convert the node to the name, I'm almost 100% sure that there is a function. Yeah, there is a function that you can get the name from the node. So that's the easiest. And then from the name to get the node, I think there's also functions. You just pass from the path, I'm 100% sure that you have a function. So it basically traverses the tree and then it searches for the node with that name and then just returns the object, the node object. So from the node name to the node object is very easy as well. Should be very easy. Then once you have those two, then the signal is already a string, so I don't need to convert. I'm pretty sure that it is a string name. Yeah, it is a string name. And then the only thing is the function name or the function address. So if I can get the function address based on the string name, I can make the callable based on the macro there. Because I'm gonna have both nodes and I'm gonna have the function address. So I'm basically gonna create this command here from the string names that I store on the class. And that's probably the best way. And the thing that matters now is figuring out what is the best data structure to store all the 4 different names that I need to recreate this command here on the connect function here, which is gonna happen every time that the node is added as a child on the scene tree. And then the caching is gonna work based on that property macro. So since I'm gonna put the member variables that I'm gonna set up to keep track of this state, they're gonna be cached automatically, hopefully, to the scene based on the macro here. And the function here is gonna be based on those values. So hopefully it's gonna be able to build the command just by using the names you put there. And then the other ones are obviously just gonna be disconnect. So this one is the one that I'm gonna be used to replace. So when I paste the editor code here, I'm going to replace all the connections with subscribe. and just pass the names there. And this is going to update the state of this. So what I think is going to happen is that from the editor point of view, once I save the scene, it's going to save the scene based on the final state, which happens after the whole code runs, which means that the class is going to have the nodes, it's going to have the member variables changed based on whatever signals were connected. And then the editor is going to load the scene state from the file, which is going to get the updated member variable values, and then is going to recreate the connection based on the event here, the event that is emitted on the scene tree. That is going to call the function that creates the connect command. I think this should work, hopefully. And I think that's the main thing that I needed outside of the other stuff that I already did, to be able to build the entire scene from the code, from C++ code. Because I think the GDScript stuff, the more that I think about it, it doesn't make a lot of, it doesn't make difference, because it's basically the same thing. Like, you can view the biggest difference between the script and a C++ class is that the script is a resource and is also a member variable of the object class. But it's possible to be able to do both of those things from C++. So it doesn't matter that much the rest of the functionality that you can do with GDScript, because you can do everything from code, from C++. And obviously, if I want to, at some point, to also add the GDScript from the editor, I can do that. You can use C++ and Godot or only GDScript. You can use C++, but it's a lot harder to learn. But I think it's worth it if you have the time, obviously. The GDScript is a lot easier to start with. Now, if you want to learn how to use C++, look into modules, and I did a bunch of streams as well, so explaining how everything works. So, yeah. But modules is the easiest way to start learning how to create stuff from C++. But if you want to create everything from code, then as far as I know, you can't really do that. And that's why I'm trying to develop this stuff that I'm developing. But modules, I think it should be, it allows you to create your own custom nodes. So depending on the way that you structure the scene, you can put all the logic on C++. If you encapsulate everything from one node. The only downside of doing that is that you're not going to be able to change from the editor if you do that. So the editor code, for example, is only one node, is the editor node. And then they do everything inside of the constructor of the editor node. So if you try to apply the same logic by using a module, then you won't be able to change the nodes on the, unless you register everything. But I think even if you register, because it's not going to show it's not going to show the child. I think that there might be a way to get around this, which is the way that I was talking about, where you add the children outside of the node, which it is probably what I'm going to try to do after. But probably modules is a lot easier in the beginning to start with. So that's basically when you create a module, it's going to show up here your node as part of the editor. It allows you to extend, and then you can put the functionality you want inside of the node you create here. The downside is that, like I said, you're not going to be able to see the children unless you add the children from outside of the node, I think. Do you have any more questions? I think I'm going to stop here. If you want to ask something. Because there is nothing that I'm going to do now. Like, I have to spend time thinking about what is the best way to structure there. And yeah, I think it's better to just don't do anything until we can come up with something. And probably what I'm gonna do is after I set up this, okay, after I set up this class like this, which I'm gonna do it, I'm gonna add this as a child of the root directly, and then cache the signals based on the events there on the sync tree. But after I do that, I'm gonna try to change this class so that this class is always the one that I use to be the root of the scene. Because then I think I can make all the functionality based on the ready events only, and I don't need to connect to this other scene trees here. Because then the ready, like the root node is going to encapsulate the entire scene. So I think that the ready is only going to run after all the nodes are added, which means that the state of the class is going to have access. Like it's going to be guaranteed to have access to both nodes, which is the important part and the confusing part about doing this, because the connection here needs both nodes, not only one of them. And it's very confusing to think about, in all possible situations, what order the nodes are added to the scene. So if you do something that doesn't connect the signal, or tries to connect the signal when only one node exists, and then you don't implement, like don't connect at that point, then there are situations where you're not gonna have the signal when you expect to have the signal. And that's the biggest problem. Like even if you check if you don't know node exists or not. But I think this way is probably gonna work, hopefully. If it doesn't, then it's gonna be very annoying. But I'm gonna try to implement the same logic that they use on the script, which is a lot harder, I think, because you have to study the serialization there, the way that they save and load scenes. So, okay, I'm gonna stop here, and next time I'm probably gonna be continuing. I'm gonna continue to do this stuff here. I'm not really sure if I'm gonna go very far after today after the stream, as I think about this stuff. But once I solve this stuff, if I can't solve like this, like I said, I'm gonna try the other approach. But if I'm able to solve like this, then the next step is gonna be to copy the code that they use to initialize the editor, put here to build the editor node, the beginning of the node, the layout structure of the editor node from code here. And then I'm going to spend a bunch of time trying to like break things on purpose to understand more how the editor classes work and how the layout structure from the editor work. So I can build functions that are going to allow me to have layouts as starting points for applications. And then I'm always going to probably start from the code, have the initial layouts, and then I'll think about the different nuances after. So